All right, so let's look at multiplicity again here. So we have this function. Now, I can't factor it, right? It's got 5 terms instead of 4, so I know I can't factor it. So we want to graph it first of all. So put it in your y equals. So x to the 4th plus 2x cubed. Oops, mean x there. Minus 11x squared minus 12x plus 36. Then go to your standard viewing window, zoom 6, and graph it. Knew it was going to do that. Let's try that again. All right. So we make our little table. So we've got the zeros. What does the graph do? And so therefore, what's the multiplicity? We know that because this is a 4th degree polynomial and I'm done, the multiplicity has to add up to 4. Okay? So we have 2 zeros. Where are the zeros at? Okay, right? Negative 3 and 2. So I have a 0 at negative 3 and a 0 at positive 2. Okay? So does the graph at those zeros, does it cross, touch, or bend? Okay, at negative 3, what does it do? It touches. Okay, what about at 2? Okay, those are both, it just touches at both of those spots. And if it touches, that means it has to be even. Okay, if it touches, it has to be even. And since I can only add up to 4, that means that both of them have to be 2. So these both have multiplicity of 2. So I have a 0 at negative 3 with a multiplicity of 2, and a 0 at 2 with a multiplicity of 2. So a reminder then, I could write these as x plus 3 squared and x minus 2 squared. So I could actually factor it, because I just did. Okay. Any others? Sydney? Well, how about you give me one first? Number 18, all right? All right, number 18 is one that we can factor. All right, so we always want to look, first thing is we want to look to see if we can factor. All right, but that would be after we get everything on the same side, because it's got to be equal to 0. So in this case then, we have x to the 4th minus 12x squared plus 36 equals 0. All right, got to get everything on the same side, and I can factor. So what are the factors of 36 that add up to 12? 6 and 6, right? Okay. So this would be x squared minus 6, and that thing would be squared then. Okay. So then we have x squared minus 6 equals 0. So we add 6 to both sides. Get x squared equals 6. And then square root. So x equals plus or minus the square root of 6. Okay, Ryan? 29, all right. Was that one that you wanted also, Sydney? All right, number 29. Okay, that's a good one. Okay, so here's another one. We want to identify all the real zeros, real roots of each equation. And first thing we want to do is, can I factor it? And I look at this and I would try to factor by grouping. So if I put those two together, I'm going to end up with x minus 7, right? X squared times x minus 7. Will I get x and x minus 7 here? No, okay? So factoring doesn't work for me. So that means I'm going to have to graph it. Okay? So we're going to put that function in our y equals x cubed minus 7x squared plus 14x minus 6. So I'm going to zoom in here a little bit, see if I can see it a little bit better with my graph. So it looks like I could get everything in from about 0 to 6, right? On the x-axis. So from 0 to 6 on the window. All right. Okay, so it's hard to tell. It looks like there might be a 0 at at about 3, right? All right, so let's see. If I hit trace, type in, oh, there it is right there. Anybody know why it did that? No, because I didn't do anything. I just, that's right, it's the center of the screen. The center of my screen happens to be at the point 30. And so it went right to that spot. And that's exactly what happens. It goes right to the middle of the screen. So we do have a 0 at 3, okay? And let's see, do I have any others? This one looks like it's around 1/2, isn't it? I wonder if there is one there. Let's go to 0.5. And nope, there's not one at 0.5. Okay. But we do have 3, don't we? Okay. So I can use 3 and then synthetic division to reduce this cubic polynomial to a quadratic. And then I can use the quadratic formula. Now sometimes, which you might have found out as you were working last night, you have to do it more than once. If I find more than one 0, okay, then I'll do it with the first 0, and then I'll do, with what I have left, I'll do the second 0 with that. So we do our synthetic division. What's that? Doesn't matter. You use one, and then when you get done with it, use the other one. Okay. So if you have more than one, you use one. Let's say, for instance, in this case, let's say we had 3 and positive 1. Right? So I could pick either one to go first, and then I would use the other one here, okay, to reduce it down even further. And if you have, oops, I didn't. I'm just saying if I had a second one. Okay. All right, so now we have, here's my A, my B, and my C to use the quadratic formula. So we get the opposite of -4 over 2 times 1. All right. Negative B over 2A plus or minus the square root of B squared minus 4 times A times C. So we get 4 over 2 plus or minus, let's see, 16 minus 8 is hopefully 8. we have to simplify the square root of 8. So 4 times 2 is 8. So then this would be 2 square roots of 2, because the square root of 4 is 2. So we have 2 plus or minus 2 square roots of 2 over 2, which is 2 plus or minus square root of 2. So I have 3 and 2 plus or minus square root of 2. Now my answer. And like I told you yesterday, you could go to your calculator now, and we could type in here 2 plus square root of 2 and find out that a equals 0 also. Okay. Right. Doesn't say 0, does it? Okay. But this is 1e negative 12. That means I'm going to move the decimal place to the left 12 places. So that means there'd be 11 zeros and a 1. That's pretty close to 0. Okay? All right, number 20. Do you want me to do number 20 or not? Okay, so first thing we write it on, get everything on the same side. Okay. Can I factor this? All right, so I have to graph it. Now, we had this discussion during first hour today, and I'm going to tell you this too, all right, before I even graph it, that if you have a leading coefficient, okay, then you probably have a 0. Then you more than likely have a 0 that has that number as a denominator, okay? Then you probably have a 0 that has that number in the denominator, okay, like 3/4 or 7/5 or 7/4 or something like that, okay? All right, so let's go ahead and graph it. All right, so let's look and see if I have zeros. I'll go to the table this time. And I have 1 at 1 and 1 at negative 2. Well, that's nice. Because, so we got x equals 1, x equals negative 2. Right. Well, I can actually find the third one. Now I can just do synthetic division with both of those then, okay, and reduce it down to a linear. Right. So, Gage, you're asking which one do I use first? Doesn't matter. Okay. So we use 1 first. 4, 7, negative 5, negative 6. So I used 1, and I reduced it down to a quadratic, right? It was a cubic, then division, it's now a quadratic. It would be 4x squared plus 11x plus 6. But I know this other 0 of 2. So then I can put negative 2 in here with these numbers, and it'll take this quadratic and reduce it down to a linear then. So we bring down our 4 times 2 is negative 8. Combine them, we get 3. Multiply, I get negative 6 and 0. So that means I have 4x plus 3 here equals 0. So we subtract 3, divide by 4, and we get negative 3/4. And what did I just tell you a minute ago, Sydney? Yep. That if we have a leading coefficient other than 1, there's a good chance that one of your zeros is a fraction with the leading coefficient as the denominator. Okay. Now let me show you something else here. I could have gone about this a different direction. Okay. Now we know that we would have x minus 1 and x plus 2, right? Okay. So it's a cubic function, isn't it? Which means then there is one more factor here. Well, what do I multiply x and x by to get 4x cubed? Okay, remember, if I multiply this x by this x by this, it equals 4x cubed. It equals the first term. And the first term is 4x cubed, so what do I multiply x squared by to get 4x cubed? Okay. So this would be a 4x here. X times 4x is 4x cubed. Well, then that means also that if I multiplied this number here and that number there, -2, and this last number then, because those are constants, when I multiply the three constants together, I better get the constant of -6. So -1 times 2 is -2 times +3 is -6. And so I actually use the factors to find the missing one. And then I could use that to find that 0, -3/4. Okay. Right. So you could do either method will get you there. Okay. Okay. So this lesson is called Fundamental Theorem of Algebra. And we're going to continue to focus on zeros, roots, x-intercepts. So here we have this nice table here. It says the following statements are all equivalent. What does that mean? Okay, they're all equal. They're all the same. It says a real number r is a root of the polynomial equation p of x equals 0. Okay. So if r is a root of the polynomial equation, then if I replace x with r, I'm going to get 0. We did that, right? Did that a couple lessons ago. It means r is an x-intercept of the graph. Okay? So if it's a root, that means it crosses the x-axis at that point. Okay? We just did that, right? We're looking at where lines cross the x-axis. Which means also x minus r is a factor. Okay, we showed factors and how the roots give us factors. When you divide by the factor, which we did with long division, synthetic division, if it is a factor, then the remainder is 0. And then we also use the terminology that r is a 0 of the function. So all these things are things we've talked about. They represent the same thing. Right? So we're going to take a look at finding a polynomial if we know the zeros. So here we have an example where we know the zeros are -1, 2/3, and 4. And instead of finding a polynomial equation, we're going to find a polynomial function. Instead of equation, we'll make it a function. So we're going to write the simplest polynomial function with these 3 zeros. So when we're done, we're going to have f of x equals something in standard form. So to be able to get it into standard form, we have to first write it in some other form. Okay? If I know the zeros, what do the zeros help me with? Okay, the factors. Okay? It helps me with the factors. So I know there's a factor of, if I have a 0 at negative 1, there's a factor of x plus 1. If I know I have a 0 at 2/3, then there's a factor of x minus 2/3. If there's a 0 at 4, then I have a factor of x minus 4. So now to write it as a polynomial function, all I have to do is simplify, which would be multiplying in this case, right? Now, before we do that, I don't like this fraction of 2/3. Anybody know how I can make that so it's not a fraction? Mandy, do you know how to make it so it's not a fraction? No? It's according to one of the division or the factoring methods we used. Okay. Remember we did slide and divide? Okay. Slide and divide, we end up with fractions, and we got rid of the fractions by doing what then, Amanda? It is 3x minus 2. Remember, with the slide and divide method, we would take the denominator here of the fraction and move it in front of the x. So I'm not working with fractions. I can take that denominator and make it the coefficient of x. And that was the thing we did with the slide and divide, is we kept doing that. Okay? So now it's just a matter of do the multiplication. Okay? So write in factored form. If there are any fractions, we slide the denominator over, and then we do the multiplication. So f of x equals what? So you guys go ahead and do this multiplication yourself, and I'll go ahead and do the multiplication too. So multiply two of them together, and then the response, the answer you get, multiply that by the third one. And when I do it, I multiply the two easiest ones together first. And then you can do that other multiplication however you want. I'm going to do it vertically. You could use a table. You could do it vertically. You can do it horizontally, whichever way you prefer to do it. Okay, because we all have our own special ways we like to do that multiplication. This lesson is called the fundamental theorem of algebra. And the fundamental theorem of algebra just basically talks about zeros. And they show it here that every polynomial function of degree n greater than or equal to 1 has at least one zero, where a zero may be a complex number. So if we have a quadratic or a cubic or a quartic or a quintic or so on and so on, that they are all going to have at least one zero. It's just that that zero or those zeros may be complex numbers. Okay? Well, when do I see a complex number? See a complex number when you end up taking the square root of a negative number. Okay? Square root of negative 5. Okay? Plus or minus the square root of 5i. Okay? Now, Reminder is that whenever we do factor them, or we do find the zeros, the number of zeros is usually the same as the degree. Okay? So we have, if we had degree 4, we're going to have 4 zeros. If we have degree 3, we'll have 3 zeros, and so on. So we're going to use this theorem so that we can write every polynomial function in factored form. All right? Okay, so here, first thing we're always going to try to do is factor it if we can. Now, this starts out x to the 4th, and there are 5 terms. Can I factor that? Okay. Can't factor it, so we're going to graph it. Okay. So how many zeros are we looking for then when we graph it? Okay. We're looking for, hopefully we'll find 4 zeros, the degree of the polynomial. Okay. So let's go ahead and graph this function. I don't know if that'll work or not. Okay. All right. Now, we said there should be 4 zeros, right? Okay. How many zeros do we see? 2 zeros. Okay. Well, but the zeros, what's the multiplicity of those zeros? What does it look like if multiplicity is 2? What does the graph do if multiplicity is 2? It touches, right? These cross, don't they? If they cross, their multiplicity is only 1, which means then there's got to be 2 more zeros, right? Okay. Now, so let's look at these two first of all. So what do we have? -1 and 4, is that right? So I have 2 zeros at -1 and 4. And I want to see what the rest of this graph looks like, because maybe I'll understand why that's the case, that there's only 2 of them. Only 2 real ones then. So if I change my window here, or let me go to the table, between -1 and 4, it goes down to -78. So I need to get at least down to -78 so I can see all of the graph. So I'm going to change my window so that my y-min, we'll try -85. Something a little bit lower than -78. Hopefully it'll show up there. I'll get to the minimum or the bottom. Okay, great, I do. I see it. Okay? Now, here's the thing, is that if I had 2 more zeros somewhere else, okay, 2 more real zeros somewhere else, then this graph would be symmetrical. Okay? Everybody knows what that means, right? That means it would come down and go back up in a nice U shape. Okay? Does that do this? No. Because it doesn't, that tells me then, and this is by experience that I'm telling you now so that you understand that, this tells me then that the other 2 zeros are complex zeros, that they're going to be imaginary. So we're going to end up with I in our answer then to find the other 2. Okay? They're not real. Okay? That's why we only see 2 of them across the x-axis, is that if they're, however many times it crosses the x-axis, that's how many real ones there are. Okay? But since we have a degree 4, in this case we only have 2 real, and we're going to have 2 of them that are complex. Well, to find those other 2 then, we're going to have to use synthetic division, because we know 2 of them, and that'll take our 4th degree polynomial down to a quadratic, to where we can use the quadratic formula if we have to. And maybe it'll even be simpler than that as far as that goes. Right? So we pick one of them. Here you go, Gage. Here's another one of those situations. Right? Which number is easier to use? Negative 1's easier to use, so I'm going to use that first. So we do negative 1, coefficients 1, negative 3, 5, negative 27, negative 36. Make sure you have every single one there. Okay? To the fourth, to the third, squared, first power, and 0. Okay, we're good. I guess I need a 1 there, don't I? I got the negative. Negative 1, here we go. Okay? So we do the synthetic division, bring down our 1, multiply, we get negative 1. So negative 4. Multiply negative 1, negative 4, we get 4, so that gives us 9. Negative 1 times 9 is negative 9, so we get negative 36. Times negative 1 is 36. So we got 0 there like we were supposed to. Okay, using negative 1. So then we take the other 0 we know, 4. And use the numbers we just got then to do synthetic division again, because I've just reduced it to a cubic, and now I want to use the other one to reduce it to a quadratic. So if I need to, I can use the quadratic formula. Okay? But this is actually nicer than that. It's nicer because I don't have to use the quadratic formula because I only have two terms. I have x squared plus 9. And I want to know, when does that equal 0? If there was a middle term here, I'd use the quadratic formula because I probably can't factor it. But since there's no middle term here, then we just set x squared plus 9 equal to 0 and solve. So we get x squared equals negative 9. Take the square root of both sides. And what happens when we do the square root of a negative? Sydney? What's the square root of 9? Square root of 9 is 3, right? Okay, so this would be x equals plus or minus 3i. Okay, the square root of the negative number squared is that number I. Okay. Okay. So my answers are 1, 4, and plus or minus 3i. So if your book or your teacher or whoever asked you to factor this, okay, I could use that information to factor it, and I would have x plus 1, x minus 4, x plus 3i, and x minus 3i. And I just use that information to write it in factored form. They didn't ask me for this. They just asked me to find all roots. Okay, so I don't have to do that, but I just want to show you that it is possible to do it then. Okay, so you can actually use your graph and zeros to factor. Okay? And hopefully you understand that by now, that is a possibility. Okay? Questions? Does it seem much easier now than when it was looking before? Okay, but the first thing, whenever they ask you to find the zeros, always look to see if you can factor first. Because there was actually a problem that we talked about first hour that on question number 32, I think it was. No. Which one was it? We did one first hour. I can't remember which one it was. That wasn't 32. It was 25. We looked at number 25, and they were having a hard time doing that. They graphed it right away, and you couldn't see the zeros right away by graphing it. But if you factor this, okay, then it was actually pretty easy though. Okay? Those of you probably know what I'm talking about who did that. All right.